Welcome students. In the previous video lecture we have completed 4 exercise of topic limits. Now in this video lecture we start exercise 7.5 which depends upon the limits by substitution method. What is the meaning of substitution method? We see in the example directly. In this exercise there are two questions, question first and question second. Question first contains 5 problems, second also contains 5 problems. So we have to see here 10 problems in this exercise. Let us start question number first. And the first problem, limit x tends to pi by 2 cosec x minus 1 divided by pi by 2 minus x bracket square. Now here we see the substitution method. In this problem we have to use here substitution method. Before that here denominator becomes 0. That is, we put x as a pi by 2 minus pi by 2 0. So we have to solve this by any way, using any method. And now to solve this problem we use substitution method, because in the denominator or numerator, majorly in the denominator we have given the difference of these two directly or indirectly. That is x minus pi by 2 or pi by 2 minus x, or 2x minus pi, 2x minus pi, or x minus pi by 2 we have written here. So we have given in the denominator direct or indirect subtraction. At that time we use here substitution method. So now let here we take always this pi by 2 minus x. Here we have given it is pi by 2 minus x, that is equal to h. Use this substitution always. Here suppose x tends to a, then a minus x is equal to h. So we get here pi by 2 minus x is equal to h. We carry this x to right hand side and h to left side. So we get here pi by 2 minus h is equal to x, means from this we find the value of x. Now here, since we have given limit as x tends to pi by 2, and if we put x as a pi by 2 in this equation, we get the value of h as 0. So as x tends to pi by 2, as x tends to pi by 2, h tends to 0 from this equation. We have to change the limit after the substitution method. And therefore now required limit is equal to limit as, now we change x tends to pi by 2, h tends to 0, h tends to 0 after substitution. Cosec of, in place of x, here x, so in place of x we write pi by 2 minus h, pi by 2 minus h, minus this 1 and divided by, now this pi by 2 minus x, pi by 2 minus x is h, so it is h square. Okay, so it is equal to, that required limit is equal to limit as h tends to the 0. Now we must know the formula of cosec of 90 minus theta. Cosec of 90 minus theta, it lies in the second quadrant, first quadrant. Here it is 0, here 90, here 180, 270 and 360. So this 0 to pi by 2 is the first quadrant. So this angle lies in first quadrant, and we know that in first quadrant all trigonometric ratios are positive. But when there is pi by 2 or 3 pi by 2, means on the y-axis, pi by 2 or 3 pi by 2, we have to change cosec as a sec or sec as a cosec, tan as cot, cot as tan, sin as cos, cos as sin. These are the pairs. So we use here cosec of 90 minus theta as pair of cosec is sec. So sec of h, it is sec of h, and this minus 1. Get it? And it is positive because in the first quadrant all trigonometric ratios are positive, and divided by this h square as it is. So it is equal to limit as h tends to the 0. We write this sec h as 1 upon cos h minus 1 and divided by this h square as it is. So it is equal to limit as h tends to the 0. Now we take this subtraction 1 minus this 1 into cos h, that is cos h, okay, upon this cos h and upon h square. Here upon h square we write it as 1 upon h square. Get it? Here h square upon 1 as 1 upon h square. Get it? So 1 minus 1 into cos h, 1 minus cos h upon this cos h, whole divided by h square. We write here 1 upon h square, and so it is equal to limit as h tends to the 0. Now we use the formula of 1 minus cos theta. We know that here 1 minus cos of 2 theta, that is equal to 2 times sin square theta. We have seen this formula, 1 minus cos of 2 theta, but we want here theta. So divide this angle by 2, also divide this angle by 2. So 1 minus cos of theta is equal to 2 times sin square theta by 2. We divide this theta by 2, and here also this angle by 2 get cancelled. So it is theta, 1 minus cos theta, that is equal to 2 times sin square theta by 2. So here 1 minus cos of h, only in place of theta we write h. So 1 minus cos of h is 2 times sin square h by 2. So it is 2 times sin square h by 2 for this, and divided by, we write this h square here and this cos h as 1 upon cos h, because we use here standard formula. So we write h square below this sin square h by 2. Now this 2 is constant, we take outside the limit. Okay, so this is equal to 2 into limit as h tends to the 0. Now here sin of h by 2, sin square h by 2 upon h square, we write sin of h by 2 upon h bracket square, numerator square upon denominator square is equal to numerator upon denominator whole square, okay, into 1 upon cos h. Now here angle of sin is h by 2, and our standard formula is limit as theta tends to the 0 sin theta divided by theta, that is equal to 1. Means here angle theta, here should be theta, and that theta tends to 0. So here h by 2, here we want h by 2, so we divide by 2 and multiply by 2. Get it? Now this 2 we take outside the limit. Here 2 and its square. So next step is here. So this is equal to this 2, and now take this 2 outside the limit, 2 and bracket square. So 2 square, that is divided by 2 square means 4, and take limit to this and this separately. And so we get here limit as h tends to the 0 sin of h by 2 divided by h by 2 into limit as h tends to the 0 1 upon cos h. Okay, now and this bracket square. Now this is the standard formula, value of this is 1, because here theta divided by theta, theta tends to 0. So we write here reason as, since here h tends to the 0, h by 2 also tends to the 0, and using the formula standard, that is limit theta tends to the 0 sin theta divided by theta, that is equal to 1. So the value of this bracket is 1, and here 2 by 4 it is 1/2, here 1 bracket square into 1 upon cos of, here put h as 0, cos of 0. So here 1 square is 1, 1 into 1/2, that is 1/2 into 1 upon this cos of 0 is 1, and so it is equal to 1/2. The solution of this problem is 1/2. Now we see here next problem. Limit 1 upon 3, second problem here, 1 upon 3 limit as x tends to a, limit as x tends to a, sin x minus sin a, sin x minus sin a upon fifth root of x minus fifth root of a. Fifth root of x minus fifth root of a. Okay, so this is equal to 1 upon 3 limit as x tends to a. Now in the denominator, here sin x minus sin a. We have seen formula sin c minus sin d, that is equal to 2 times cos of c plus d divided by 2 into sin of c minus d divided by 2. So in the numerator we use this formula sin c minus sin d, that is equal to 2 times cos of c means here x plus d means here a divided by 2 into sin of c means here x, d means here a, so x minus a divided by 2, and we write this fifth root of x as x to the power 1 by 5 minus a to the power 1 by 5. We modify this problem like this. Now here we use the standard formula of sine, that is sin theta upon theta, theta tends to the 0, means we have to adjust here x minus a divided by 2 in the denominator to use the formula. Means here we have to divide this numerator by x minus a and also denominator by x minus a, because if we use here in the denominator, if we divide this as x minus a, we have the standard formula limit as x tends to a, x to the power n minus a to the power n upon x minus a, that is equal to n into a to the power n minus 1. We have seen this. So we divide numerator and denominator by x minus a. Divide numerator and denominator by x minus a. So it is equal to this 1 upon 3 as it is. Limit this 2 take outside the limit, so 2 into 1 it is 2 upon 3. So 2 upon 3 into limit as x tends to a, cos of x plus a divided by 2 into sine of x minus a divided by 2 and whole divided by this x to the power 5 minus a to the power 5. Now we divide numerator by x minus a, so divide this by x minus a and also this denominator by x minus a. Okay, now here we have to adjust here standard formula, so we have to divide this by 2. Okay, so divide this by 2 and multiply by 2, and now here so this is equal to 2 by 3. Limit we separate limit to every term, that is limit x tends to a, limit x tends to a cos of x plus a, x plus a divided by 2 into, we take this 1/2 outside the limit, that is 1/2 into limit as x tends to a, sine of x minus a divided by 2 divided by x minus a divided by 2, and divided by limit as x tends to a, x to the power 1 by 5 minus a to the power 1 by 5 divided by x minus a. We take the limit to every term separately, and now here we use standard formula. Since here x tends to a, x tends to a means x not equal to a, means x minus a not equal to 0. Therefore x minus a upon 2 not equal to 0, and therefore x minus a upon 2 tends to 0. X minus a upon 2 tends to 0. So the value of this limit is 1. Since we have the standard formula limit theta tends to 0 sin theta upon theta, that is equal to 1. Theta divided by theta and theta tends to 0. So question may be arises here x minus a divided by 2, here also x minus a divided by 2, but here x tends to a. So I have given here reason. Since x tends to a, x not equal to a, therefore x minus a not equal to 0. Divide by 2 on both sides. So x minus a upon 2 not equal to 0. So not equal to 0 means tends to 0. Therefore x minus a upon 2 tends to the 0. So even we write here x tends to a means here there is x minus a upon 2 tends to 0, and therefore the value of this limit is 1. And now here we put directly x as a here, and here use the standard formula. Which standard formula? That is limit as x tends to a, x tends to a, x to the power n minus a to the power n upon x minus a, that is equal to n into a to the power n minus 1. This is the standard formula. So here 2 upon 3 into this cos of x, in place of x we take here a, so a plus a divided by 2 into this 1/2 into 1 and divided by here this 1 upon 5, n into a to the power n minus 1, n is here 1 upon 5, a to the power 1 upon 5 minus 1. Now this 2 and 2 get cancelled, okay, this 2 and 2 get cancelled. So here it is 1 upon 3, this cos of a plus a, that is twice a divided by 2 into this 1 into this 1 upon 5 we write 5 upon 1 into here 1 upon a to the power this 1 upon 5 minus 1, that is 1 minus 5 into 1, 1 minus 5 minus 4 upon 5. Here we write this 1 upon 5 as 5 upon 1, okay, and so it is equal to now this 1 upon 3 into 5 upon 1, 1 into 5 that is 5 upon 3 into 1 that is 3. Here this 2 and 2 get cancelled, so it is cos of a, and here take this a to the power minus 4 by 5 in the numerator, we get a to the power plus 4 by 5. So this is the final solution for this problem. Now we see here third problem. Limit x tends to pi root of 5 plus cos x, root of 5 plus cos x minus 2 upon pi minus x bracket square, pi minus x bracket square. Now see in the denominator there is pi minus x, limit x tends to pi and pi minus x, direct subtraction, so we use here substitution method. Also in the numerator there is root 5 plus cos x minus 2, so we have to rationalize the numerator also. So we write firstly here, let put here pi minus x, this pi minus x is equal to h. From this find the value of x, carry here x on the right hand side and h to left side. So pi minus h is equal to this minus become plus x, okay. Now here here as x tends to pi, if we put here x as a pi get cancelled, so h is 0, so h tends to 0, okay. Therefore required limit is equal to, we write here under root of 5 plus cos of, instead of x now we put here write limit as, here limit as h tends to 0, limit as h tends to 0 under root of 5 plus cos of, in place of x we put here pi minus h, that is pi minus h, okay. Now this minus 2 and divided by this pi minus x is h and it's a square, bracket square, so here h square, okay. So this is equal to limit as h tends to the 0 under root of, now this pi 5 under root of 5 plus here cos of pi minus h. Now see here, this is the first quadrant, this is the second, third and fourth quadrant. Now pi minus h, this is pi. Pi minus h means in the second quadrant. Okay. Now in the second quadrant, sine and cosec is positive. Sine and cosec positive, remaining are negative. So cos is negative in this second quadrant. So we take here, we change this plus sign and take minus. Why we take minus? Because cos is negative in the second quadrant. We have to use the formula for cos of 180 minus theta. Now 180 minus theta, cos of 180 minus theta, that is cos. That is equal to cos of h. When there is 180 or 360, here 180, here 360, then cos is cos, sin is sin, tan is tan, etc. But when here pi by 2 or 3 pi by 2 on the y-axis, then we change cos as sin, sin as cos, etc. We have seen in the previous example. So here, since this pi minus h lies in the second quadrant, and in the second quadrant cos is negative, so we change this plus as minus. And here 180 on the x-axis horizontal, so cos is cos, so cos of h. And this minus 2 and divided by h square. And now we rationalize the numerator. Okay. So limit h tends to the 0. Limit h tends to the 0. This root of 5 minus cos h minus 2 upon h square as it is into root of 5 minus cos h. Instead of this minus, we take here plus divided by 2 and same in the denominator. That is root of 5 minus cos h plus 2. Now we take the product of numerator. Okay. Here we use the formula a minus b, a plus b, that is a square minus b square. So it is equal to limit h tends to the 0. A square means root of 5 minus cos h square minus 2 square divided by this h square into this, or we may write here in the bracket root of 5 minus cos h plus 2. So it is equal to limit as h tends to the 0. Here this square root and square get cancelled, so it is 5 minus cos h, and minus here 2 square is 4 divided by this h square into this root of 5 minus cos h and plus 2. Now here 5 minus 4. 5 minus 4, it is 1. So it is equal to limit as h tends to the 0, 1 minus cos h. 1 minus cos h upon this h square. And we write this separately, 1 upon under root of 5 minus cos h plus 2. Why we write this separately? Because we use the standard formula for this. We write now 1 minus cos h. We have written in the first problem 1 minus cos h. That is 2 times sin square h by 2. So it is equal to limit as h tends to the 0. That 1 minus cos of h is 2 times sin square h by 2 divided by this h square into 1 upon under root of 5 minus cos h plus 2. Now we take this 2 outside the limit. So it is equal to 2 into limit as h tends to the 0. Sin square h by 2 and divided by h square, we write sin of h by 2 divided by h bracket square into this 1 upon under root of 5 minus cos h and plus 2. Okay. Now here sin of theta divided by theta. Theta is here h by 2. Here h. So divided by 2. And into 2. We adjust this 2. Okay. Now take this 2 outside the limit. That is 2 square. So it is 2 upon this 2 square is 4. And separate limit to this and this. So limit as h tends to the 0. Sin of h upon 2 divided by h upon 2 bracket square into limit as h tends to the 0, 1 upon under root of 5 minus cos h plus 2. Now here theta divided by theta and theta tends to 0, then the formula is 1. Sin theta divided by theta, theta tends to the 0. Here h by 2 divided by h by 2 and h by 2 tends to 0. We must have here h by 2 tends to 0. But since here h tends to the 0, h by 2 also 0. Put h as 0. 0 divided by 2, that is 0. So h by 2 tends to 0. And using formula, standard formula, limit theta tends to 0, sin theta divided by theta is equal to 1. Always write this step. Always write formula on this side. So we get here 2 upon 4, that is equal to 1/2. Value of this is 1 and bracket square into 1 upon under root of 5 minus cos of, here put h as 0, so cos of 0 and plus 2. Okay, this 1 square is 1, 1 into 1/2, that is equal to 1/2 into 1 upon under root of 5 minus cos of 0 is 1 plus 2. So it is equal to 1 upon 2 into 1 upon under root of 5 minus 1, that is root of 4. Root of 4 is 2 and 2 plus 2, that is 4. So it is equal to 1 into 1 in the numerator 1 and 2 4s are 8. So 1 upon 8. So solution is 1 upon 8 for this problem. Now here next problem, fourth problem. Limit x tends to pi by 6. Fourth problem, limit x tends to pi by 6, cos x minus root 3 sin x, cos x minus root 3 sin x divided by pi minus 6x, pi minus 6x. Now see, so it is indirectly subtraction of this. If we carry 6 here, 6x, 6x tends to pi and pi minus 6x. So indirect subtraction of this. So we use here substitution method. Here let put here this pi by 6 minus x and it is equal to h. Get it? Pi by 6 minus x. Always take this minus this is equal to h. Now from this find the value of x. Carry this x on the right side, h on the left side, and so we get here pi by 6 minus h is equal to, this become plus x. Now since x tends to pi by 6, as x tends to pi by 6, here if we put x as pi by 6, pi by 6, pi by 6 get cancelled, h tends to 0. Always here h tends to 0 in every problem in substitution method. Now the required limit is, is equal to limit as, we change limit, as x tends to pi by 6, h tends to the 0. So limit as h tends to 0. Cos of, in place of x, we write pi by 6 minus h. Pi by 6 minus h. Minus root 3 sine of, in place of x write pi by 6 minus h. Pi by 6 minus h. Divided by, we have to write this pi minus 6x. So pi minus 6 is pi minus 6 and put the value of x, that is pi by 6 minus h, pi minus 6x. So pi minus 6 and put the value of x as pi by 6 minus h. So it is pi minus 6 into pi by 6, 6 get cancelled, that is pi, minus minus plus 6 into h, 6h, this minus pi and plus pi get cancelled. So value of this is 6h, we write here directly 6h, get it? Now in the numerator we use the formula cos of a minus b and here sin of a minus b. We know cos of a minus b is cos a cos b plus sin a sin b, and sin of a minus b, that is equal to sin a cos b minus cos a sin b. Okay. So this is equal to limit as h tends to 0. Use here cos a minus b,
that is cos A means pi by 6, cos B means here H. Now in cos we cross the sign, here minus, take plus, sin A sin B, that is sin of pi by 6, and sin B, that is sin H. This is the formula for cos A minus B. Cos A cos B plus sin A sin B. In cos formula cross sign, here plus, here minus, here plus, here minus. Okay, but in sin minus, plus, sin, same sign. Okay, now here this minus root 3 as it is in bracket. Now sin of A minus B, that is equal to sin A into cos B. B means here H, sin A cos B, here minus sign because sin same sign, and then cos of A here pi by 6 into sin of H, and whole divided by 6H, okay. So it is equal to limit as H tends to the 0. Now this pi by 6 means 30. Pi by 6 means 30 degree. So what is cos of 30 degree? Cos of 30 degree is root 3 divided by 2. So it is root 3 divided by 2 into this cos H. Okay, plus here sin of pi by 6, sin of 30 is 1/2. So 1/2 into sin H. 1/2 into sin H. Now here this minus root 3 into this. So minus this root 3, and now sin of pi by 6. Sin of pi by 6 is 1/2. 1/2 into 1/2 into this cos H. Now this minus root 3 and this minus, this become plus root 3. Okay, plus root 3. Cos of pi by 6. Cos of pi by 6 is root 3 divided by 2 into this sin H. And whole divided by 6H. Okay, so this is equal to limit as H tends to the 0. Now here this root 3 by 2 cos H, and here also root 3 into 1, that is root 3 divided by 2 cos H. This one is plus, this one is minus, so get cancelled to each other. Okay, now here remains 1/2 sin H. This plus root 3 into root 3 divided by this 2 into sin H, and divided by 6H. So here sin H. So it is equal to limit as H tends to the 0. Now here denominator is 2. So 1 sin H plus 3 sin H, that is 4 sin H. 4 sin H, and divided by this 2. Denominator same, so we take the addition of numerator. Here 1 into sin H, that is sin H, plus 3 into sin H, 3 sin H. Sin H plus 3 sin H, 4 sin H, and upon this 2, and divided by 6H. So it is equal to limit as H tends to the 0. Now this 2 ones are 2, 2 twos are 4. So 2 sin H upon this 6H. Okay, now take this 2 upon 6 outside the limit. So it is equal to 2 upon 6. 2 upon 6 outside the limit into limit H tends to the 0. Limit H tends to the 0 sin H upon H. Now this 2 upon 6 2 upon 6, that is 1 upon 3. 2 ones are 2, 2 threes are 6. So it is equal to 1 upon 3, and this is the standard formula. This is 1, so it is equal to 1 upon 3. So solution of this problem is 1 upon 3. So in this way we have completed here fourth problem. Now the last problem of the question number first. Limit as x tends to 1, 1 minus x square upon sine pi x, 1 minus x square upon sine pi x. Very important example. Now see here, we write this example. This is equal to limit as x tends to 1. Now here 1 means 1 square. 1 means here 1 square minus x square. So factor of this is 1 minus x into 1 plus x, using the formula a square minus b square. So it is 1 minus x into 1 plus x divided by sine of pi x. And now here there is indirectly subtraction or direct subtraction here, 1 minus x in the numerator. So we use here substitution method. Also whether denominator is 0, if we put x as 1, sine of pi into 1, that is sine of pi, and sine of 180 is 0, we know. So denominator becomes 0, we have to solve this problem, and we solve this problem using the substitution method. Why we use substitution method? Because we have given the subtraction of this in the numerator. So we have to write here, let put 1 minus x, this 1 minus x is equal to h, and therefore 1 minus h is equal to x. Now as x tends to 1, h tends to, here put x as 1, 1 minus 1, that is 0, so h tends to 0, and therefore this required limit is equal to limit as, now we change x tends to 1 by h tends to 0, so h tends to 0. Here 1 minus x is h, okay, in the bracket 1 plus x is here 1 minus h, and divided by sine of pi into x. So x is here 1 minus h. We take here round bracket 1 minus h. So this is equal to it is equal to limit as h tends to the 0, h into this 1 plus 1, that is 2 minus h. This h as it is, 1 plus 1, 2 minus h, divided by sine of, we multiply by pi inside the bracket, that is pi into 1, pi, minus pi into h, that is pi h. Again see, in the denominator, sine of pi minus theta. First quadrant, second, third, fourth. Pi here, pi minus, it lies in the second quadrant. And in second quadrant, we know that sine is positive. Therefore, here, limit as h tends to the 0, h into 2 minus h. In second quadrant, sine is positive. So we take sine as positive. But here, it is 180 pi. So sine is sine. So sine of pi h. Okay, when it is on the y-axis, we change sine as cos, cos as sine. But on the x-axis, sine as sine, cos as cos, etc. So here, sine of pi h. So it is equal to limit as h tends to the 0. Now here we have to use standard formula, sine theta divided by theta. So this h we carry here. So we get here this 2 minus h as it is, and sine of pi h divided by this h. We carry this h in the denominator, or we may say here divide numerator by h and denominator by h, same procedure. Okay. Now here this is pi h, we want here pi, so we take this pi into this pi. Okay, and now this pi, which is constant, take outside the limit, and so it is equal to 1 upon pi, this, and separate limit to numerator and denominator. Limit as h tends to the 0, 2 minus h, and limit as h tends to the 0, sine of pi h upon pi h. Okay, now sine of theta divided by theta, here should be theta tends to the 0. So we may write here reason as h tends to the 0, pi h also tends to 0. Because if we put here h as 0, pi into 0, that is 0. And using standard formula, limit theta tends to 0, sine theta divided by theta, that is equal to 1. And therefore the value of this is 1. And here we put directly h as 0. So we get here, so this is equal to this 1 upon pi, 2 minus 0 divided by 1. So it is equal to 2 minus 0, that is 2. 2 into 1, 2. And divided by pi into 1, that is pi. So the solution is 2 upon pi. So in this way, we completed here 5 problems of question number 1st. In the next video lecture, we will see question number 2nd. We stop here. Thank you.